Looked at it at all in grade 10 or 11 to this point, but we're looking at statistics. It's something that was introduced to you probably around grade 8 or 9. So the first thing that we need to do is we need to talk about measures of central tendency. Okay? And measures of central tendency, there's 3 of them that we primarily use. Now statistics is quite interesting going into this election next week in the United States, let's be honest. Okay, any election for that matter, but there is an election coming in the United States. It's in 8 days. So right now they have all these polls out. Okay, and what are the polls? The polls are questionnaires or people phoning and doing surveys, and they're taking results. So for example, let's say that hypothetically they wanted to find out who the new mayor of Roblin was going to be, and they polled all of you in the classroom. You'd be considered a sample of the entire population of the town. Now yours might be a little more biased because you're all the same age and you're all the same grade level. All right? So what would be another way in which we look at finding out what the results are going to be? Well, we might take 1 from each grade, or 2 or 3 from each grade. Or you might just do the whole population of the school. Okay? It's a way in which you can do it. So they use sample sizes to find out who's leading in the polls. Who's going to win the next election is based on sample sizes. So they phone an area randomly. I don't think it's ever random. Each party has their own polling system, so they all do it and they phone the areas that they want the best results for. I think is exactly what happens, and then they sway everybody from it. Okay? So where this all starts is this. We're going to look at measures of central tendency today, which is the start of statistics. And there's 3 ways in which we measure central tendency. Mean, median, and mode. Okay? You seen these 3 words before?
Yeah.
Yeah. Okay, so what is mean? Average.
Just kidding.
Yeah.
Pointed
Today
yourself.
you made
Pointed
the right
yourself.
Today you made
What
the
did you say? You didn't say anything. He's like, what does it mean? And I went,
Class.
Hey, at least you
Median.
smile.
he always smiles at me.
Median. What is the median?
Isn't
No,
the
no.
middle?
The middle number. All right. Is there anything else we need to do to get that value though?
You have to order the
Oh, order.
least greatest to greatest least.
Right. From lowest to highest,
And
it's your middle number, right?
if there is no middle number, don't you take the 2 center ones?
And you divide.
Yeah, good. You guys got this. We're good at
Or you divide them by the 2 together. 2?
Your average.
Yeah.
Okay. Then you add them together. And then the mode is what? Somebody remember what the mode is?
Is it the number you have the most of?
Yes.
Yeah.
Most frequent, right? Most frequent or most occurring. Okay? Yes,
So
Marshall.
what if there was no like reoccurring number? So if it was 1, 2, 3, 4, 5.
Then you can write there's no mode.
Okay.
Right? That's fine. Okay, so just judging, I don't think, does everybody in here have a graphing calculator right now? Who does not have a graphing calculator? Put up your hand. 5 of you? Okay, 6, 7. All right, so we are going to have some work to do. These are done a lot better. We'll do as much as we can without the calculators, but then we may have to go get some calculators for it. All right, so let's look at this data here on the example. Greenhouse gas emissions in tons per person were recorded from 1990 to 2005 between Canada and the United States. Construct a graph to illustrate the GHG emissions for both countries. All right. So looking at the 2 graphs, along the bottom, your timeline almost always goes along your bottom. Okay. If you use time for anything, it'll go on your x-axis. Then up the side, they had the CO emissions in tons per person. All right, so the greenhouse gas emissions per person for Canada and the United States. And in the margin over here, they have the actual data to tell you. So the average per person in 1990 in Canada was 18, and in the US it was 22. In Canada it was 18 in 91 and 21 in the US. So what do you notice about the 2 numbers? What stands out to you right away between the two numbers, the two sets of data, sorry. Anybody give me anything?
US is higher?
All the way through?
No, the US is pretty consistent.
US is pretty consistent, that's right, okay? Right, they maintain between 21 and 22. Anybody have, and I'm just throwing this out there, I don't know the correct answer to the question, but does anybody have an indication as to why that might be? Why would Canada's be able to fluctuate as much as it does and the American states pretty,
Canada doesn't have as much people.
okay, that's a definite possibility, right?
Like
For sure.
everything's maybe more spread out, so there's more people driving from the places.
Okay,
But they
so,
watch it more in the States.
alright,
And then
No,
there's
they
more
watch it more
public
here.
transportation as well, so it's not.
okay, so all very valid, right? Bigger populations, possibly demographics, Canada's much bigger with fewer people, right? My thoughts personally would be that there is an actual limit as to,
Yeah.
because it's also including factories and there's probably a limit on it as to how much is allowable to be produced in the United States, and it can't vary from that at all. So they are monitored maybe a little bit differently than what Canada is, okay? Because you can see Canada goes pretty high in like 1995, up to 27 tons per person.
I wonder if that's changed just now.
Yeah, right, because we're in 2005 right now, right in the book, right? But we're 9 years later, right? Or 11 years later. 11 years later, right? So maybe we do have that change. That's for sure. It's a possibility. Okay. All right. So then it says determine the range, the mean, the median, the mode. Oh, I didn't add any range here. What is the range of your data?
The least number and like the smallest number and the largest number.
So the difference between the highest and the lowest, right? Highest and the lowest, take your largest number and subtract your smallest number. In this case, what's your largest number for Canada?
27.
27, what's your lowest?
16.
16, so that's a range of, someone else did math, it didn't work for me.
11.
11,
Hey, look again.
okay. Yeah. All right, 21, 22, so what's the range in the Americans then? Just one, right? Okay, so then we could calculate the average by adding them all up and dividing by the number of them. And in this case, we'll just use the book to help us with our answer. So Canada's mean is actually 21.25, which is exactly the same as what the Americans was. 21.25 over that time period. The median, when you go lowest to highest, the median for Canada was 20 and the median for the US was 21. And then it says, how do two countries compare in the amount? Examine the trends in the graph and the values from part B to compare the data from the two countries. Graph showed the US was more consistent. And it's exactly what we said. Okay? So, mean, median, mode. All right, let's flip over to 112 right now. We're also going to do some work with graphing. Okay? So we have frequency tables, histograms, and polygons. Or polygons. Man, I'm having a tough day here. Okay, to display a large set of data, you can use a histogram or a frequency polygon. To compare two more sets in frequency tables, use frequency polygons. For a histogram, plot the frequency data on the vertical axis and intervals on the horizontal axis. The graph looks like a bar graph with no spaces between them. For a frequency polygon, plot the frequency data on the vertical axis and intervals on the horizontal axis. The graph looks like the line graph from the midpoints of each interval joined up. Blah, 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 blah. Okay, what does that mean? Well, I want you to look in your book at the graph given to you on top of page 113. Okay, so if you're looking at it, they label the dates along the bottom by their intervals. So 1980 and 1983. 83 to 86, 86 to 89, and so on. So when they do the histogram, they put the frequencies of them. So this is your frequencies, that's how often they occur. Right there, right? And then your timeline, your years down here. Okay, and the histogram graph looks like this. So it's the same as a bar graph, but no spaces. Okay? So what they did is they used intervals. Instead of plotting all of them, they used the intervals. So 1980, 81, 82 was all put together. So in 80, 81, 82, we're looking, sorry, I didn't read the question to you. The table shows the number of earthquakes measuring 7 or greater on the Richter scale that occurred from 1980 to 2009. So instead of putting 29 years down on there, all right, we're going to just break it up into 3-year intervals. So the first one was 80, 81, 82. How many earthquakes measured greater than that?
37.
37, that's right. So you would put that down. Now, I've shown you what a histogram looks like. The frequency polygon is you take the actual number and put it in the middle of those. And then join the dots with a line. And that's called the frequency polygon. So it's not very complicated. All right? And I'm just kind of flying through this because I just think it's pretty easy for you to figure out. So I'll just leave that for right now. What I would like today